Okay, we are talking about Docker today. Thanks for being here. Let's end early, okay? So we can get home because it's Friday, or go back to doing research or whatever. Whatever we're supposed to be doing right now. Okay, you all watched the video on Docker? You all understand it then? Perfectly? Great, then we're done. I thought it'd be interesting to talk about it in the context of Python and Python environments. I think I talked about that a little bit in the video. I don't quite remember. I watched it 2-speed and only part of it. But it always helps to talk about motivation, right? That's always a helpful thing. So I was thinking we talk about the motivation behind this, what Docker does for us. And I wanted to show you kind of like a demonstration of how it kind of all comes together. In my opinion, it won't be a full comprehensive demo, but it'll be kind of, we'll start with WebCrawler and see how do we put this into a Docker container and all the problems that come along the way, or why we want to do that. Okay, so first of all, so remind me, why do we need Python environments? It's virtual environments. What problem was that to solve? You remember? So like the VM, yeah?
Yeah, it was like, so if you had certain projects that needed to have certain versions of packages or whatever, you could install it only personally to that environment, and that way it wouldn't affect all the other projects that were on your computer, so you wouldn't like mess yourself up on one project.
Yeah, so when you do pip install, by default that installs in this global computer pip, which maybe that's what you want, but probably you don't want that. It might be specific to a certain project. So there's just kind of keeping your global pip repository or whatever, folder, executables all clean. That's one reason you want to do that. Also, maybe you don't care about cleanliness, so who cares? I don't know, I can't see it, whatever. But there can be issues where maybe if you work on 2 different Python projects, they could have conflicting requirements. One could say, oh, I need version 2 of this library. This one that says I need version 3 of this library. We haven't had a chance yet to upgrade to version 3 yet in this other project. So you can actually have issues where you have conflicting requirements and there's no way to resolve it except for pip uninstall and pip install the other version and then run that project. And when you want to switch back, quickly uninstall it and install the new one. Now, obviously, that's not very scalable. And so why make one global pip, one global environment? We can have multiple environments for each project. There can also be things with different Python versions as well. Maybe you have an old project that's been around for a while that supports Python 8, but then you're like, well, I want to start this new project. I want to support Python 9 or Python 10 or something like that. So even Python versions can become a source of issues. And so you want these environments that can be separated. So very good. And so we accomplish that. Remember, we create this virtual environment and it puts everything into this .vm folder or any folder, whatever we want to name it, but it puts all the executables into a folder. And then it does a bunch of trickery with our path, right? So it says, oh, don't point to that one Python. If I do which-all Python 3, don't point to this Python 3. Point to the Python 3 that's in your virtual environment instead, or don't point to that pip. Point to this other pip. You can see my path is messed up. Apparently, I got multiple entries. So that's how it performs. That's great. But the question is, how do you make this portable? Anyone know what I mean by portable? How do we make it work on one computer and then work on another computer? I would say for the most part, you don't care about that much in college, right? You just need to work it on one computer and show the TA and get your points and you're good to go. So one computer is sufficient. Maybe you've run into this issue where you worked on it on your laptop, got it all working really nice, and then you go over to a lab machine and all of a sudden things are different. We usually kind of keep things nice and clean for you, so that probably won't happen, but that could happen. But as soon as you want to have it work on one computer and try to port over to a different computer, all bets are off. Things get really messy quick. And I will say before I get into that is that Python, what we showed you in this boot camp so far with Python, it's not unique to Python. Other languages have the same issue. If you have some kind of repository where you can download dependencies, then you need to have dependencies, contained for each project. You can't have one global that's sufficient. So Ruby has Node.js has this problem as well. All different solutions for this. And those all work great, but don't they those only capture like dependencies that pip can represent? What about things that we had like apt-get? Then all bets are off. I just ran it, and the times it can be both. I was just trying to install something called PyTables, and you need to install the Python pip bindings, but you also had to install a binary using apt-get. So that's an example where you needed both of those to work together. And so pip, if you installed pip, installed it, it would say, hey, you haven't installed it this other way yet. But so if you brought your pip, your requirements.txt from one folder to one computer to another, you wouldn't be able to do that, capture all those dependencies. This gets worse when you become a developer and let's say you're doing like backend. Remember what backend means? Context of the web. It means the server side, front end, the web browser kind of stuff. Backend. You want to treat servers kind of like disposable entities. So you want to be able to spin up an instance of a server really fast, install all the software you need to as quickly as possible, then spin up 5 or 6 servers if you want to. So there's to spin up servers fast and get all the software you need on them as quickly as possible. But there's also, you're not working on a server typically for your day-to-day development. So you're working on your laptop or your desktop in front of you that you have at your desk. How do you make sure that all the stuff you've done work that on your computer will then just move over to a server really easily? Because there's all these little gotchas, and I'll demonstrate that in a second or a little bit. So there's all this to say that it's really hard to get all the dependencies just through pip or just through these different means. And so that's what Docker is trying to solve. Anyone had experience with Docker? A little bit, okay, cool, awesome. So Docker is trying to take that, trying to say, we will build containers. And you remember from the video, there's a picture, like shipping containers. Say, well, can't we just have a standardized form in which we can package all of our software in? Why not? Why have custom ways of doing this? Just have one standardized way, so containers. That's what Docker is providing. One standardized way to package up your app, all the dependencies, and then so you can ship it to wherever it needs to go, whether it's your colleague's laptop or a server somewhere, or you want to spin up 5 different servers rather than having to type out the commands for that for each 5 servers. You just, here's the Docker container, install it on all of them, and you can automate that really easily. Any questions on that so far? So Docker is not a required skill, but I think it's an important skill to learn. Something that we won't teach you ever, but I think it's fun to kind of work on in your own time and experiment with and get proficient at, because employers are interested in that, because especially if you're doing backend development, that's a really important way of capturing all of the essence of what your application is. So, okay, let's go over this. Let's show you an example of kind of how I'd walk through Dockerizing something, kind of the thought process that goes along with that and the gotchas we have. Yep.
Just real quick. So trying to kind of get the differences between like virtual environment and then Docker. So like, because virtual environment has all of its dependencies like inside of itself, where it can just call inside of its own environment and everything's fine. And Docker is kind of the same way, but just in a standardized way where it can be shipped off to any other like device and still be used inside of its own environment.
Yeah, well put. Yeah, that's a really good high level overview. How it achieves that, we haven't answered, right? And I won't answer for you, except that it abstracts a file system. So it's any files that you change, it will capture that. So it's at the file system level, which is much more detailed than, hey, there's a special folder that contains Python code. Hopefully that moves around with you. And but that doesn't capture all, like, what does that depend on the apt-get libraries or other libraries that are installed on your computer. But if you capture that at the file system level, then you're guaranteed more likely to catch all the dependencies. And so you can think of maybe if you're trying to containerize something, pip install or these virtual environments being on one end of the spectrum and like a virtual machine being on the other end. Those are like opposite extremes. Like one's like much more lightweight. Here's a folder, has all the executables in there. Make sure you switch your path to point to that versus like, we're gonna abstract all the hardware down to the hardware level. That's what a virtual machine does. We're going to pretend that you have your own core. Here's your allocation of RAM. You have access to this. You're just a machine running. You don't know anything about, you're just a virtual machine. Docker's in the middle somewhere. It's not completely abstracting the hardware away, has access to all the same hardware that your computer has access to, but it's kind of in a more contained environment. So essentially we'll spin up, say, your own separate thing. Here's your file system, but you have access to all the same hardware as the underlying operating system does. So it's not virtualizing any hardware stuff. Yeah.
How is Docker similar or different from the Windows Linux subsystem?
I don't know enough about the Windows subsystem to answer that question. Sorry. Anyone know the answer to that?
Well, at least partially. So what they do with the WSL is they abstract out the calls to the operating system. So from the programs that are running in your subsystem for Linux, it really thinks it's talking to Linux, but there's no Linux underneath the hood. So when it makes a call, for example, like open a file, so it has to transition from the user space to the kernel space. Now you're trying to support the function in the kernel. Well, when it makes that call, like open a file, and it traps and goes across, well, there's no Linux kernel running out of the hood. So what Windows has done is they've provided an emulation of opening that just like Linux would, so that your programs that are running in the subsystem for Linux think Linux is running underneath, but it's really Windows doing the hard work.
Thank you. And I will say it does get confusing. For example, I'm pretty sure the Docker application actually creates a VM on a Mac and on a Windows version. So there is VM mixed in there, but it's because it's designed for Linux only, really, Docker, but they want to support everything. So they actually will create a VM for you that gets loaded up on the fly when you start Docker. It kind of runs off the side. At least that's how it's on Mac. I don't know about Windows, but they don't need to do that because of this underlying system. Because it's relying on some features of Linux, and it's able to separate different processes from each other and provide access. Great questions. Any other questions on Docker? High level overview. But I hope to motivate it by showing you an example, kind of just the pain points. And, honestly, this won't be that painful because it's such a small app and there's not that many dependencies, but like multiply by 10 or multiply by like a deadline where your boss is breathing down your back or you have a paper to write, then it starts feeling a little bit more real and you realize, okay, this is maybe more necessary. But yeah, I'm okay if we get going. So this is our web crawler that we wrote. Exactly the same. Oh, no, not exactly the same. I did add this. I want to know when is it going to print, when does it start to show the date. So if I'm like scrolling through, I can kind of see. So let's run it just to see where we're at. It's Python 3 web crawler. Okay, so where we have an issue, of course. No BS4. I am not in a virtual environment. Okay, so let's create a virtual environment. So already I have issues. So pip or Python 3. So this magic incantation to create a virtual environment. Okay, cool. I'm in this virtual environment. Okay. Now you can see right here, I'm in this virtual environment now. So if I do, Python PHP, so the version I'm at, or no, let's do pip. This will show me. I always run this just to kind of make sure I'm in the right place. It's showing me where the pip executable is running from. Okay, sure enough, it's running from my virtual environment. Great, so that's the right pip. Sometimes you can get tricked up. Okay, so now if I run this again, it should have the same error. I don't need Python 3 now. Okay, cool. So then I'll do pip install. Sorry. I meant to do this before. Okay, I couldn't remember. There's they have the capital one is beautiful soup 3, and you want the 4 version. So I couldn't find it. Okay, so there we go. Install that. Okay, run it. It's still not going to work. Okay, install requests. So imagine, and this is actually probably what you guys have been experiencing because research is not well defined. But imagine you start your job and someone says, "Okay, here's this Python code to run." And you're like, "Okay," and then you run it, it doesn't work. You're like, "Oh crap." Okay, this is, I mean, anyone feel that way? That's how I feel sometimes, like someone gives you code and of course it doesn't work right. So like, it's really annoying. Like if you're new to Python, like, I didn't know I was supposed to create virtual environment. I didn't know I'm supposed to pip install this stuff, but so you're nodding your head because I know in my lab we had this issue. Okay. So it's kind of annoying. It's like, I got this code I wanted just to run. Why am I having to figure out all these dependencies? Okay, finally, running along. Okay, let's just kind of see how it's going.
The virtual environment also contains any libraries that are contained on the computer itself, right?
No,
Oh, no, it's just base Python.
yeah, just Python. So just if you run Python. Pip. Okay, this is interesting. We got error. This is shows the brittleness of web scraping, right? Is someone, I might guess, I mean, look here, it's saying I was checking to make sure the length of the href is is greater than 0 because we have empty href, but it's saying a none type. So my guess is what happened is someone put an a tag without an href in it. It's my guess, and so that shouldn't be allowed, but you know, it's HTML and people do crazy things on websites, and so here we are. So we have to deal with that. So that's something we didn't have to do before, right? Because that worked fine like last week when I did this. So if href is none, then let's just continue. Nothing we can do. There's nothing worth scraping there if href is nothing. So, oh, okay, this is nice. It said, hey, knows I like to use black as my formatter, so it's installed in my virtual environment. Great. Well, thank you. Okay, let's run this one more time. Make sure we cut that error. Okay, showing us the start time, and then remember, it's showing us all the instances of different words. Obviously, it's not very well done because you know, we got the empty string in there. And honestly, if I were to do this again, I'd probably remove like the and. I want interesting words, not just like boring words like the. Okay, there it ran. Okay, cool. 61 links. Okay, so now we got it running. So we want to now move this up to some kind of server somewhere, right? Let's say that, or our buddy's laptop, something like that. So we got to be beautiful and say, okay, well, let's freeze our environment. Let's see what are all the packages we captured, what are the packages we installed to make this possible, so that they don't have to go through the same pain that I just went through. So that's pip freeze. You can pipe it out to, or pip freeze shows you that. That's helpful, but I like to, you know, requirements.txt. That's just convention. It can be named whatever you want, but just in Python, standard convention is to have a requirements.txt, and that contains your pip freezes. So here it's pinning all my different things I've installed to a certain version. So that way it should work. If Beautiful Soup updates it to version 5 and changes the API completely, it won't matter because I'm saying no, version 4.11.1 is my version, and I can test it out and change it if I need to. Okay. You with me so far? Okay. How do we get this to the server? Okay. How do we get this to the server? Just so happened I have a server right here called Docker demo. That's nice. How do I go? Don't mind that. This is a brand new server, never been touched. Just had to delete a few files. So how do I get the files from my computer to the server? What would you guys do? No wrong answers.
CP.
SCP. That's a very sane answer. I like it.
You could make a GitHub.
GitHub, very good answer as well. I was expecting answers like, which are valid because they're often easier. Email it to yourself. I've been there. Do it. I mean, it doesn't make so much sense on a server. We hopefully get away from that, but I'm not against doing Vim and copying and pasting. I've done that way more times than I should. You know what I'm talking about? Like, I go like here and say, okay, Vim web, or you know, do nano dot as well. Then you just go paste. Done. File is there. That's probably not a good solution. That's not okay. But you know, we've been there. Okay. I think SCP is a good one. Let's use Git. Let's do Git. This will be like a summary of all the stuff. So Git, init. Now we got some Gitness going on. Okay, cool. But we need some kind of central server. So I'll go here, GitHub, okay, repository, called Docker demo. I have not practiced this part of it, so let's make it private just in case. Oh, I'm gonna put it in there yet. Okay, and then it gives us handy instructions. Say if you already have a repo, we don't need to follow these because we do have files there. So let's go get up. Okay, bring this up. Cool. We don't want, okay, yeah, right now we don't want VM in there, right? That would be bad. We don't want to commit that. I could just say, oh, stage all. It's gonna take a while because it's got so much. Look at all the stuff it's committing. We don't want that. We only have like 2 files that we really care about. So we don't do that. Let's unstage that. Okay, so now we have to do, okay, git ignore. Remember, git ignore, we can just say a folder name or a file name, it'll just ignore it. And VS Code is very kind and it highlights that by graying it out. So, okay, that's been ignored for us. I go back here, sure enough, yep, we'll have 3 files now that we need to commit. Our git ignore file, our requirements, and then the web crawler itself. Cool. We'll commit. Okay.
What was that window you brought up? Just get up.
Yeah, it's Mac specific.
I have MacBook.
Okay, good. Yeah, just download that. GitHub is name of an app that does Git stuff for you, open source, and then you can install a command line utility that will essentially, when you call GitHub, it'll just bring up the web or not the web, the app. You have to click on an icon like a sucker. Just take it. Like a hacker. Okay, initial commit. Okay, cool. But it's only locally on my computer. I commit it there, but I want to push it up. But it's saying, well, it's gonna, oh, it won't even let me do that. There's nothing to push up to. Like, where's up? I don't know. I mean, I can do git remote -v. Like, there's no remotes. There's nothing there. Okay, so that's what Git is trying to say. If you already have a repository, which now we have a repository, you've committed to it, then just run these magical commands. It's gonna add that origin, and it's gonna tell it to push that main up to the origin. You don't have to understand what it does. Just paste it. Okay, cool. Enough now, both match up the origin. If we go here and refresh, awesome. We've got our files. Cool. Okay, let's go to this. Do I have Git? Good. Git clone. Oh, no. Dang it. Psych, let's make this public. So I don't want to set up my keys for this. So how do I make this public? Change, sure, yeah, let's make it public. I understand, okay. Be very careful about that. Okay, all right, now it's public, so now we clone it. That's what we want to do. You understand why I did that? Because on my server, it doesn't have permission to access my private repositories. I would have to set up SSH key, which is not hard to do, but I just don't want to do that right now because I'm going to delete this server and like once I'm done with this. Okay, git clone. So we're trying git clone. So it's going to go to this URL through SSH, download it, download the whole history. Yes, I trust you. Public key. This is going to make it really hard. Okay, don't ask questions. We got it on there. Phew. Okay. It's there. Okay. Requirements and where's git ignore? Okay, it's there too. Phew. Okay, so we got the web crawler. Great. Let's. Now we can't just run it, right? That won't work because we don't have the virtual environment set up. I mean, let's try it and see what happens. Okay. Doesn't even know Python. Okay, we need Python 3. Okay, so let's set up our environment. So let's do Python 3, what is it, -vm.vm. This looks really tricky, but it's just saying load the VM module and then save all that to the .vm file. I can name this whatever I want, foobar, is the convention. Okay. Okay, awesome, did that. Okay, so now we have this VM thing here, so we can do pip install. No, I'm going to activate it. So let's see, source. and then activate. Okay, now we're in the virtual environment. We got this little thing to indicate to us we're in the virtual environment. Great. So Python, I always like to double check. Python. My pip is now in my virtual environment. So if I leave my if I do that pip v just to see what it looks like, normally it's going to not even say you have pip. So that's an indication that we're in a virtual environment because pip is not even installed on this. Let's go back into that. Source, let's source that again. Source. Sorry. Okay. Cool. So we're in the right place. So let's do pip install and then read in requirements. Okay, so we had to do that. That's kind of annoying. I mean, it's not a deal breaker, but that's kind of annoying to have to do that, right? It'd be kind of great, like, especially let's say you had to do this 5 times on different machines because you're bringing 5 different servers because your app is so popular. That'd be kind of annoying to have to do that, but maybe not a big deal. Okay, let's run it. Now this should work, hopefully. Huh. What is this? Using time zone, okay, import. So let's just look at the line it's complaining about. Go here. I'm using time zone information so I can print out the date time. Okay. That's weird. This one didn't complain about that. Anyone know what's going on? Why did one complain about it but not the other? No one should know the answer to this. I'm using 3.9. What about this one? Dang it, 3.8. I use the 3.9 feature. How dare I? So right there, what do we do now? The answer is I don't know. You have to pip install 3.9, and that's a whole headache. So now this one task of it's just to install the requirements. That's it. It's like no, now it's like actually now I have to switch the version of Python. I have to install that, and that's a headache. So this is a long way of saying let's use Docker instead. Okay, so multiply this pain by 10 because you're stressed out. And you're on a deadline, you have to do this for 5 other servers. You have to remember all the commands. So you start making a notes or a setup.sh that will install these things for you really quick. But then you switch, oh, this one is Red Hat Linux, but this one over here is Ubuntu. And it's not apt-get, it's other thing. And it starts kind of boggling your mind. And then you want this to work on a Raspberry Pi too. And that's ARM processor and not, so it's, so this is a painful process. And so this is what Docker's trying to solve is. Let's abstract away all this stuff. Let's just make it work. You tell us what version of Python you want. You tell us what you want this environment to look like, and it'll just create a little. You can think of it like a little virtual environment, not really, or a little VM virtual machine, but it's something that's much lighter weight than that. So, what makes a Docker image is the Docker file, which is very similar to the make file. Similar name, you see the play on words there. And this is the recipe for how to make your image. So this is what you need to do to make your image. What's great is typically you only have to do this once on one computer. I'll try to demonstrate this. I'm not confident I can actually do this in front of you all. But you make your recipe. And what's cool about it, because it's abstracting at the file system level, Docker, once you make it, just say, okay, gather up all the things you changed to the file system and then just upload those changes up. And it does it really efficiently. It does it in layers and it diffs the layers. And so you're only uploading one copy of something rather than like taking a whole copy of your hard drive and uploading. It just figures out what's been changed about the base image and then uploads that. And so you only have to build this image once and then you just upload all those changes and it knows how to recreate that on any other computer. It says, okay, start with this image and then change this file to add this, change this file here, put these folders here and link these this way, and then it should be done. Okay. So from every Docker file has to start with the from. What is the base image? What am I starting from? We'll start from Python 9. Watch the video. I highlighted what this does, but this is saying someone's created a recipe already for us for Python. Look at what it went into that if we want to. but we don't need to. But someone sent, Python organization said, hey, here's a Docker contained image with Python already pre-installed. Someone figured out how to install it and installed 3.9. This is the tag part. So there's the colon, and there's the tag. So we could have said 3.8, we could say 3.10. We could say whatever version we want here, 2.7 if we really don't like ourselves, but we won't do that. So 3.9. So we're saying start with this image right here. Someone's created for us. And then now from then on we're going to now modify that image in various ways that are meaningful to us and get our application running, but it knows where to start now. Okay. So what we would like to do is, like, what do we want to do to set up this image? We want to do a pip install requirements, txt. And then let's just say, like, we want to just run this. So we kind of want to do this, right? Did I miss anything? Like, this is what we'd like it to do. Is like, yeah, use Python out. We're assuming Python's here, install requirements, and then run the application. Yeah, Carter.
Since there is only one version of Python installed, we don't have to worry about pip3 or Python. Is that right?
That's a good point. Yeah. In fact, we can like examine this as we go. We can see what Python 3 gives us. Maybe we're not, is that the right one? Because there's so many different versions you can have. There's the Python Slim version. There's the Python on certain architectures or different, base packages. And so we can go ahead and do Docker run Python 3.9. And so what this is doing is it's saying, I was not able to find Python 3.9 locally on your computer. So it's going to find it from the internet, from Docker. And then here's all the different layers of it, different changes that someone has made to the file system to make that image. Apparently they already existed. I guess I didn't wipe it clean enough to show you. Normally it has to download something and decompress it. Okay. Let's see. So this runs it. So it start up a container and then close a container because it's just running Python. What is Python supposed to do if it does nothing? So we can add the -it, say, let's make it interactive, meaning I'm going to have a keyboard when I hook up to this and bring up a terminal for it. So when you say, oh, okay, you want to bring up a terminal, then I'll give you the REPL because what's Python going to do? It's not a terminal emulator. So it'll give you the REPL. Okay, cool. So I can go in here and print test. So we can do, let's run bin/bash instead. So this last part says, run it in interactive mode with the terminal, but don't use the default command. The default command is just run Python REPL, run it in bash instead. So now I can examine what does this image give to me? Where let's look into let's do which -all Python. Okay, so it's in there, user. Let's see, do we have Python 3? Yeah, we have Python 3. We have like Python 3.9. We have that, Python 3. Or I already did that, sorry, it's Python. So we can kind of start playing with it if we want. It's kind of see what does it give us, So it's helpful to, if you're going to use a base image, to know what it's giving you. So yeah, because they might have decided, no, we don't want to even give you Python 2 or like the word Python. We're only going to give you Python 3 because we don't want to confuse you. But in this case, they gave us both. Yeah.
For this one, you said you only specified you wanted Python. You wanted Python 3, and so 3.9, and then it automatically gave you, is it Ubuntu, and on top of that Python 3.9.
Yeah.
So then you said instead of going to the Python 3.9 whatever it's called, you want to go to Ubuntu. So it's like it's layered with Ubuntu first by default, and then Python 3.9.
Yeah, I'm not sure if Ubuntu's first, but it might be. We can look at it. But something. We're not saying go to Ubuntu. We're saying run this command here, and so we can look. It's if this if bash wasn't in here, then it wouldn't work. So it's just because it's inheriting from Ubuntu, let's say, then it has a slash bin/bash in it. But if they had started from something completely different, maybe it wouldn't have that. So that. Yeah, so there is a hierarchy to it. Kind of, it's default. We can quickly say, well, let's try it out. Like, okay, let's. Not do that. So every time I'm including this, it's deleting a container, or it's not deleting it, it's exiting the container. So it's really fast. It's not like a virtual machine where you got to boot it up and let it run the operating system. This is so much lighter weight. I'm just tearing them down and bringing them up willy-nilly. Who cares? So let's run the REPL. Okay, and I'm gonna put this in. Okay, that works fine. Cool. So 3.9. Let's bring up 3.8. So this case is it's some of there's common. This is probably the Ubuntu part. This is the base image, but I had to pull in some new stuff that was only just for Python 3.8. Now I'm in 3.8. See 3.8. I'm sorry, I can make this bigger. It's kind of small. Paste this in there. Sure enough, it doesn't work. So this is a Python 3.9 feature only, not 3.8 as shown here. So really easily we were able to switch between Python versions. John, did you have a question?
Yeah, I was wondering, like, is it a good idea to use the virtual environment and Docker, or is it like kind of one or the other?
That's a good question. I use both. You could use both. You don't have to use both. Yeah, I guess how I like to do it, and this is my personal preference, is start out in a virtual environment and kind of build the app, because that's the fastest, kind of easiest way of doing it. I'm most familiar with that. And when you're getting ready to move it over to server, then start testing in Docker as well, and kind of work out through those kinks. And once you have it working in Docker locally on your computer, then it should magically just work on the server. Fingers crossed. That's what they're trying to solve. That's what they get the big bucks to do. It's not always the case, but yeah, so that's a really good point. And they can coexist. They're actually fine to coexist. It's more of a convenience at that point. You don't have to do that though. So let's make so this is what we'd like to do. This is not quite the syntax of a Docker file, because this is like, bash script, right? This is like things we're running. We need to tell Docker certain things about it. So you have to prefix these things with like a run command. Say, hey, run this command. And then there's the command. And this is saying, if you don't provide any commands, like how I provide the bins/bash, if you don't provide anything, then go ahead and just run this command. So that's what's going to, so by default, it's going to run Python WebCrawler. Do that. Let's see what happens. So the command we do is, if we're going to build an image, is build. And then you say, we need a tag, we need some way of identifying this image. And so it's going to be philip.bl/webcrawler. And then say, well, where's this Docker file? And so it's dot, it's right here. It's not right there. So that's not going to work. Run this, and it's not going to work because there is no Docker file here. So let's there. Okay, now we're there. So let's do that. Okay. It's not as interesting as I thought. So it's creating the image. It already cached everything though. Exploring images. Oh, I know why. Okay. It's not doing pip install stuff because all these commands are running inside the container. So does this container, know anything about requirements.txt? It's its own kind of container. It's its own separate world. Like, so we need some way of saying, hey, here's requirements.txt. So it's commands like copy. You're going to copy requirements. So this is where are you writing this from? This is like from the your computer to the Docker container. That's spelled wrong. Okay, requirements to there. There's one also helpful thing when you deal with this is typically you don't want to do this. It defaults to the root environment of the root directory of the container. So typically there's like dir. It's like do everything from this a certain directory. Often it's like /app or code or whatever you want to name it, but often that's it. Like do everything relative to my /app. Again, it's going to copy over requirements to this /app directory, and then it's going to run this command. So now it should know what requirements.txt is. Build this again. So now it's kind of cool. It's showing you like your inception. It's like it's running that command and sees it's got the same output as if you ran on your computer in your own computer, but it's doing it in the container. So that's kind of cool. And then it's finished. Okay, so let's try running it. Okay, Philip, EL/WebCrawler. Okay. So what it's saying is, I told it to run this command. I tried to run that command. I can't find this file here though. /app, that's the work dir, right? It's web crawler. Okay, well, that makes sense. I haven't told it to copy over. I did copy over requirements, but I didn't copy over anything else about my environment. So, okay, so what we can do is copy this kind of shorthand. It's like everything from this current directory, I mean, copy it over into the app folder. Because remember, everything now is relative to this app folder. So it's going to copy it to that. So how Docker thinks about this, before we run that command, how Docker thinks about this Docker file is that each line is a layer. Each line is one of these lines right here. So it's running 4 lines because there was 4 lines. First base image, then work dir, and then copy that and then run that. There's tip here. Where do we install it? Like it's all broken down to layers. Each layer has a different hash. Remember what Derek told us about? Each has a different hash associated with it to identify it. So Docker is sensitive to how these layers are constructed, right? If you're building a building, you need to make sure your foundation is good. If you can't just switch floors and expect everything to work. And so same thing here. If I like decide to change things around, like I don't know, like this, it's going to have to restart over. Say, well, you disqualified all the layers it was built on before, because now you insert this new layer. So now I have to reinstall the whole thing. So it's going to have to reinstall that again. So you got to be really careful if we now run it again, because it's cached, because nothing's changed. It will just say, oh, nothing's changed. And so it'll be much faster. So that's a great thing about Docker is you can have a command. I've had commands apt install these 500 libraries, and it can take an hour, but you only have to do that once, as long as you never change that line again or never put a line above it. So you want to be really careful about that. Let's move it back because it doesn't really make sense to do that. I mean, it does, but I just don't like it. So what's it going to do now? So there, because I both versions cached, it didn't worry about it. It could use the cache versions. See the word cache there. So it's a really fancy way to build a system that's reproducible. You say, well, apt-get install this, apt-get install that, and then you don't have to ever pay that price for running that software and installing it again unless you change that line. So really complex build systems can be integrated into Docker relatively easy, because as long as you always work below it, then you don't have to, you can just use those cache layers again. Okay, let's Docker run this thing. This is a lot of work just to do something that we just were already able to do before. Okay, what's happening here is by default, Docker does not output the buffer. That all the data is being collected until it exits out. I don't know why they chose that. So now exit out, now it prints it out. That's not how Python works by default, right? Python prints out line by line. As you print lines out, it prints it out as well. You can get that behavior by adding the -t. I think why they do that is because Docker is meant to run anywhere, everywhere. So why am I printing out to the console if there's no console? You have to say, hey, I have a terminal. I'm running this from bash in a terminal. Please print it out. Kind of be normal terminal behavior. And then you start seeing what it is. So what this is doing for us is it's bringing up a Docker container with all that is encompassed in what Python 3.9 is, with this recipe that we just, with the requirements, pip install, and it's running this command for us. And of course, go in here, say don't run my default command. Let's run that bash so we can kind of explore it a little bit. So by default, it puts us in the app because that's our working directory. And then look, sure enough, all our files are in there. In fact, I think like all our files, even like in a virtual environment, even we didn't tell it to use a virtual environment in the Docker container, right? It said pip install. What pip is it using? It's using the standard pip, but it doesn't matter because it's its own little thing. But it did copy over. When I did this copy, it copies over everything, including my virtual environment. So there's a whole Docker ignore system as well, similar to git ignore. We say, hey, when I say copy over everything, don't really copy over everything. And VM would be a good example of not to copy over because it doesn't hurt anything, but why is it there? It's just making your image bigger. We can run this if you want to. It should be exactly the same as what we just did. And start exploring, like, is there Vim in here? No Vim. Docker tries to keep its images as small as possible because that takes up extra hard drive space. And like, if you need Vim, install it. But if you don't need Vim, why is it on every single image just to run a Python app? Like, you don't need that. And so they're really careful about what they install there. So it's really lightweight. Okay, cool. So now, are we back to where we started? Pretty much, we run it locally on our machine, but now it's all been through Docker. So let's now get into the server. Should we? Okay, this is the part I'm not so sure about. I like to show you the preferred way, which might not work. Similar to how we said, well, we have this code here. How do we get it to the server, this code? Okay, let's do it on Git, Git and clone it. Docker has a similar system for Docker images. That's where like the Python came from, called Docker Hub. GitHub, Docker Hub. And so I created a Docker Hub image for my web crawler. And this one I'm not so sure about if this will work. So in theory, it's telling me I can just push to it with this V1. Let's do this. All right. Let's try one more thing and then we'll give up on this and do it a different way. Let's do docker.io. Saying push refers to this button. Okay, and then well, I couldn't figure that out. I was doing this right before. So there's some way to push it to the repository, and then similar to you can do a git clone, you can do a Docker pull, and you can pull it on. And you don't even need the source code running in GitHub. I mean, you need it for other reasons, but you don't need to clone it on all your machines because it's all encompassed inside of this Docker container. Unfortunately, we can't do that. That's my own, just they've changed how they do this system, and so I'm just not familiar with it. So what we'll do instead is we'll just push up our changes. This is not as optimal, but I do want to illustrate. So push that up. Okay. Git clone. No. Git pull. Okay. Now we got our Docker image. Now we do Docker build. This is the part where you shouldn't have to do this part. You shouldn't have to build it twice. You should just have to build it once and then distribute it. But here we are. So like I said, you shouldn't have to do this, but let's do the same kind of thing as downloading. Here we're actually showing my system already had these cached, and so it didn't do this quite, but this is a brand new server, so I haven't done this yet. So it can take longer, but it only has to do this once. It's cached those layers. And so a lot of systems depend on these top layers. And so you only have to do this once for a lot of different systems. So here's like the Python part of it. Let's do git or a pip install. Okay, so there we go. If I do this command I did here. Run it now. So without having to worry about, well, what's the virtual environment? Okay, what Python version you're using? It's all encompassed in that one image. And so I don't have to know anything about the image really just to get it running on my machine. It works. It would be a lot cooler if I could just do a Docker pull. Docker is a fantastic way of encapsulating really complex projects. Sometimes I don't necessarily think you need to use it for everything. You can use it for everything, but as soon as you start having to get dependencies that are outside of just like one realm of Python and have to, apt-get install things, then Docker starts paying dividends, and that you don't have to worry about that. And like have a README file where say, before you run pip install, make sure you do apt-get install these things first. And then, if you're running on an ARM processor, then you have to run this command instead. Or if you're running on Red Hat, then do this. Rather than having that README file that has all these kind of corner cases, you can just encapsulate it in a Docker file. And there's lots of projects that have done this for you. And so it's really convenient. I mean, on the video, I showed you like Pi-hole. You want to watch that video? We'll talk about that. Pi-hole is a complex project. It's got a server component too. It's got blocking. So, but just through one command in Docker, you can install all these dependencies. And so you can say, well, I'm going to have a database component in my Docker container. I'm also going to have some application logic. I'm also going to have a web server that handles an API. And so you can encapsulate that all into one Docker container. And it makes it really easy to give to your coworker and say, hey, try this app. And it'll just magically work. Okay, now go install on the server. And then when your application gets more popular, say, okay, now I need to have 5 different servers and load balance between them all. So I can just repeat this step on all these different servers without having to worry about what Python version. If you do switch to a different Python version, then just update your image. And then everyone just pulls down that image, new image, and then it all is updated, it all updates itself. So it's a great way as applications get more and more complex, which I think nowadays most applications are pretty complex. Docker really helps you deal with the complexity. Any questions? You all still on Docker now? Yeah, go play with it. I mean, that's the best way is playing with it and trying out an application. Honestly, I would not use it any of your coursework. That's because there's been lots of hours where I spent trying to debug weird Docker behavior, and that's probably worth it if you're getting paid to do that. But if you're like getting a grade for it, then don't, then Docker isn't part of that, then I would not suggest doing that. But see if you can integrate into one of your personal projects or into maybe some research that you're doing. But it's a great tool. I think a lot of people should know about it because it seems to be how a lot of development is done nowadays in companies.
You need to install Docker Desktop or anything like that to use this?
Yeah. So you do have to have a Docker installed on all your systems.
So can you give us kind of a sampling from like a large Docker project to like a smaller ones as to what the size of these containers might be taking up on your system?
That's a good question. This shows how big these images are. So my WebCrawler image was almost a gigabyte big, which to me is quite hefty for a tiny little bit of Python code. It inherits that from the fact that it's inheriting from Python, which Python itself is quite large. So it can be a problem with the hard drive space. There are alternative versions of Python, which I talk about in the video. If we go here, Docker Hub Python. So this is the official image for Python. And this actually is pretty informative of kind of what's going on behind the scenes for Python. So there's a 3.11 branch. It's in beta still, but you can download it and test out the beta if you want. But there's a lot of things going on here. This is essentially saying, what version of Python do you want? Dash, what version of the base operating system do you want? Buster, Alpine Linux is a more slimmed down version of Linux. There's Slim Buster. And so we can download one of these if you want to and see how big it is. Just copy this. Docker, what is it? Run, there you go. Sorry, Python : once again, I can't find it locally, and so it's going to pull down. So notice how a lot less layers the slim version is. So 3.10 slim is only 110 megabytes. So we could try it out. I don't know if it'll work. There are differences in choosing the slim version versus regular version. So I could do dash slim. Is that what it is? It's a dash. So try running that. It's having to download the 3.9. Weird things will be like, I was doing bin/bash. It might not have bin/bash in it because they removed that in a slim version. It might have ash or some other kind of thing. In this case, it worked. We'd have to actually run it to see, to make sure it runs properly. Yeah, so right there, I could save some space by doing that. Now my Docker or my WebCrawler container is only 71. Now, where did that extra 661 megabytes come from? They came from my pip installs. And there are certain special ways I didn't show you here. Say, well, pip, one thing it does is it downloads all the source code, all the zip files or gzip, and then unzips them and installs everything it needs to. You can actually tell pip, say, don't cache those files. Right now, I think they're cached. Remember, if you change anything about the file system, Docker will capture that and have to store it somehow. And so there's ways to run pip where you say, don't cache it to try to reduce the size anymore. So there's kind of a different, where normally a caching would be a good idea because if you have to install it again on a different environment, it'll just say, oh, I can get it from right here. But in this case, because we're trying to minimize the size and it's already cached anyways, Docker's taking care of caching it, then we don't want it to cache it twice. Does that answer your question? Is that?
Thank you.
And so if we just real quick go to someone, like what is, to show us what the Docker file looks like. And these are a little magical because there's a lot of intricacies going on here. But you can start seeing it's just running bash commands at the end of the day. It's doing the wget to download the source code from python.org, FTP, and it's going to verify that the key is correct, so no one's modified it. And then it's going to make a dir for it, a directory for it, untar it, remove the directory, and it's going to change it. So it's really this is how you make Python. If you want to make Python from a source, this would be a pretty good way to follow. And then it calls configure, and then maybe calls cmake somewhere, and this doesn't calls make. But this is the recipe. So I didn't have to figure that out myself. Python did for me. But these are all things you have to do to make Python work in your system. I could do it. I could copy this code here and paste it into my Docker, and then I could modify it. Say, well, I want this extra flagged in my configure that's different than kind of how the standard Python comes. So you can do all those things. But if you are fine with the kind of standard base images, then you don't have to do any of this work. So if we go up here, see, this is based on Debian, the Buster version of Debian, whereas like this one, it's different, it's built pack, that has its own kind of weird things to it as well. So that's what the difference is between those two. And there might be other differences as well, but pretty much just trying to accomplish the same thing. It's trying to install Python and from source, but just where's the base image coming from? Okay. Any other questions on Docker? Okay. Thank you for being here. Thank you for a great boot camp. Hopefully this was productive for you. Give us feedback, please. This is a relatively new thing. This is only our second year doing it, and we've changed how we did it from last year. So if you didn't like it, let us know kindly. If you did like it, let us know. Or if you have suggestions on things, the live Q&A is was a new idea. So please give us feedback on things we could do better for next year. But thanks for being here, and we'll see you later.